Hello, this is Tim, and today I'm going to be talking about IPv6 made easy. This topic will cover the Cisco ICND1 and ICND2 topic of subnetting. I figured I'd start off with what everybody fears is subnetting. Okay, well, it's actually easier subnetting in IP version 6 than it is IP version 4. What you see before you is one of my routers that's configured. I have no IP version 6 commands. You can see that. Okay, so this is what I'm going to be configuring. I'm not going to be doing a lot of stuff. I'm just going to be showing commands and a few other things. So the first thing I'm going to talk about is, I'm sure by now you read a little bit of IP version 6, so some of this stuff is going to sound familiar, but I'm not going to go in depth. If you want more in-depth topic, I recommend picking up some books, doing some research on the internet. It's out there. First thing is, IP addressing is 128 bits long. It's that simple. I'm not going to be writing out 128 bits. I'm not even going to write a full IP version 6 address out. I'm not going to talk about shortening the IP version 6 in this particular topic today. I'm just going to be showing the shorthand version IP version 6, but I'm also going to be showing how to subnet it. Because on the exam, they're most likely just going to ask you simple, very, very simple IP version 6 questions. There's no gotcha questions. Okay. First thing is, most likely you're going to see a question that's going to ask you, how do you enable IP version 6 on a router? Well, it's actually easy. We're just going to go into global configuration mode, and we're going to type a simple command, IPv6 unicast routing. And this command will enable IP version 6 on the router. You can do IP version 6 commands on the interfaces and protocols all day long without typing this command, but nothing will work how you want it with IP version 6. You have to type this command and then it will enable the router. Some images will not support IP version 6, so you're going to have to make sure yours supports it. And some images won't support certain routing protocols with IP version 6. OSPF, I've found that it's pretty commonplace to find that in almost any of the 12.4 images I've tested, but it's very rare to find a 12.4 image that supports IP version 6 with EIGRP. So I have a version 15.1 image on this router, and I had to upgrade the RAM of the router and the flash in order to support that image. And then you just type that command, and now IP version 6 is enabled. We can check that by doing a simple show run. And here you can see IP version 6 unicast routing. So now we know it's enabled. Well, the next question is, how do we configure the interfaces and subnet them correctly. Well, let's do that. Let's go into interface fast Ethernet 00. Why not? So with IP version 4, you would normally do this, right? And blah, blah, blah. And that's how you configure the IP address. Well, it's the same thing with IP version 6, except that command. Okay, and then you're going to whoops. There we go. IP version 6 address, and then just type in the address. And we can type in another number. Why not? Now, how many bits do we have here? Well, let's count them. We have how many? Well, let's count the characters, and then I'll explain that. Okay, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So we have 16 characters. You only see 15, but if you've been studying, you already know there's a 0 that goes there. I just shorthanded it. So there's 16. So why is 16 significant? Well, if you take 16, multiply it by 4, you'll come out with 84. So let's do this again. We haven't quite reached the halfway point. So let's do, oh, I don't know, A8, B2. Why not? That brings us up to 20. That's not quite halfway. 24 is going to be our magic number here. 3, 0, 0, I don't know, F. Sure, why not? So now we've got 24 bytes. And let's multiply that. Or 24 bytes, excuse me. Yep, that's exactly what I want. Now let's do another one here. And now we have 30. I'm just writing this down so I don't have to keep counting. And then let's do one more. Okay, let's count what we have. We have 1, I'm just going to count sets. 1, 2, 3, 4, 5, 6, 7, 8. We have 8 sets. That's our magic number. 8. Now if we take 8, and we know each one of these represents 16 bits because they're in hexadecimal, we can go 8 times 16. And it's 128. So that is a 128-bit IP version 6 address. It's not really that complicated. You can pretty much make it up as you go along, at least in the lab. And then we have one more option we have to do. That's right, the subnet. Now, with subnetting, we've always wanted to do something like this. I'm just going to type a random number here. Always want to do /24 instead of doing this, right? Well, with IP version 6, you can do that. And most likely, that's what you'll see. The most common subnet mask you'll see is /64. So that's what we're going to type. And then this will give me Whoops, I can't type that character. Okay. This will give me that portion of the address, my network portion. So that's going to identify, well, that's going to identify the network, basically. So just like in IPv4, there's a network portion, there's a host portion. This is the network portion. Usually that's going to be given to you. And then the rest of this is going to uniquely identify the host. I'm not going to press enter here. I'm going to do something else. So anyways, that's the host address. Well, with the A, let me highlight the A. There we go. That's the host address. So that's going to uniquely identify the host. How do I know that? Well, we know, I'm just going to teach this really easily. We know that an IPv6 address is 128 bits long, right? We know our subnet we want to use is 64. So 64 is half of 128. That's how we know that half of this address is our network portion, because that's what our mask tells us. Now, when you get other numbers, such as 52, you'll see that number too. All of a sudden the math is, well, what do I have to do for math? Well, you're going to see a lot of different things, and I have not seen this method yet. I like using the divide by 4 method. It's something I came up with. Somebody else might have came up with it before. I don't know. You'll see other things. I'm not going to talk about them. I use divide by 4. Why? Because all you have to do is count. Take 52, divide that by 4. What do you get? You get 13. Okay, why is 13 important? Because we're going to count 13 characters. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So we've counted 13, and those represent the network part of the address. That's right, it's that easy. There's no reason to do any complicated math. No matter what you change the number to, it's going to be divisible by 4. Okay, so let's try a different one. What do we do? Well, 48. You'll see 48 a lot too. So 48 divided by 4. In case you're wondering, I have the math already done on a piece of paper here, is 12. So I'm going to count 12. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I know you're seeing a pattern, and I'm going to talk about that in a second. Alright, that's it. 12. That's our network. It's that easy to subnet. I'm going to mention one thing here, because you've already reviewed, hopefully, the shortcut methods. You know that there's a hidden character here, and I keep deleting it and retyping it. So when you see this question on an exam and you start counting, don't forget the invisible 0. Okay? That invisible 0 will mess up your subnetting. So if you have to, just write it down. Write down the whole address. If it takes you an extra, 15 seconds on the question just because you're writing down that whole address, then that's what it does. The important thing is you get the subnetting accurate. Okay, so I'm going to leave the invisible 0 in there right now. That's what I'm going to call it anyways. Okay, notice there's no let me start over. Notice there are no other shortcut methods I've incorporated into this IPv6 address. Okay, as I'm not going to talk about the shortcut methods, I'm just talking about subnetting. Alright, so is this going to work all the time? Oh yeah, it's going to work. You know, 4 goes into 24. Oh, well, okay, we've been doing numbers below 64. So let's do another number. Let's do 72. Well, let me do the math here on the piece of paper. And yeah, okay. So 72. You might see numbers higher than 64, and that's not a problem. That's easy to deal with also. Same method. You're going to count after you divide, into, let me say this again. You're going to take 72, divide it by 4, and you're going to come out with 18. Well, I don't want to count 18 all the time. I know these are in blocks of 4. So I can even take that one step further and just say 4, 8, 12, 16, 20. Oh, wait, got to go back one. 16. And yes, I did that on purpose. 17, 18. Now we know this is our network portion of the address. That's right. It's that simple. So you divide by 4, what? Twice. You can even do that. So if you take 18, divide that by 4, you're going to get 4, and then remainder, what? That's right, 2, which is what we have, right? We have 4. You know what? I'm just going to highlight this. We have 4 right here. Remainder 2. It will work every time. There's not going to be an extremely difficult subnetting question on the exam. I would be surprised if there was. I mean, this is just basic stuff. So it's that easy. Now, most likely, I'm just going to erase my line here. Okay. I'll leave that one up there. And I will go back into my interface. And retype the command. Most likely you're going to see something along this line. Whoa, what does that mean? Well, there's another shortcut method in there, the double colon. And you should already know what that means. If not, well, look it up. It's the same thing. What is the network portion of this? Well, we've done 64 in the past. We know 4 divided by 64 is 16. And if we take 16 divided by 4, it's 4. What do we have here? We have 4 groups of numbers, or characters, because they're hexadecimal. And pardon me if I say numbers, I should be saying characters. Okay, so we know we have to count 4 places. Well, we have 4 places already, so we don't have to count anymore. We know before the double colon that is the network portion of the address. And this 1 identifies the host. Think of that 1 as in, like, I don't know, 192.168.0.1. If I was to change that, 0.2. 2. It's pretty much the same. Okay. It's not any more complicated than that. And I can hit enter and that'll work. Oh, it doesn't like me. Oh, because it's overlapping. What did I do? Oh, okay. So it overlapped. So apparently when I hit Control Z, I might have hit enter instead. So let's do the no command, and there we go. Now it'll work. Okay. Bear in mind, I'm not using a Windows box, I'm using a Mac, and the program I use, some of the key combinations may be kind of funky. So yeah. So I put up with that, but it's fine. So there's my address. Well, let's just check it. And there it is on Fast Ethernet 00. That is my address. It is that easy. I'm not going to go set up another router and do ping back and forth because it's an IP address. You see IP addresses all the time. You can lab it. It'll work. So, and just so you see the version I am using for I have an 1841 router. I'm using version 15.12T. So yeah, that's the version I had to use. IPv6 subnetting made easy. Okay. You don't need to do complicated math. Don't listen to those other books who tried making you do all this weird stuff. Okay. It's simple. Practice it a few times. If you can do basic algebra, you can do this. You don't even have to do basic algebra. You can do basic arithmetic. Just that's a better word. Okay, so thanks for listening. I hope this has helped you. Let me know, and I will try to, stay within the topic of subnetting. For this video, I'm going to make other videos later on that's going to talk about other topics with IPv6. I'll be talking about the shortcuts and in the UI64, what all that means, and link local, all that stuff. So I'll be going over that one at a time, and I'm going to try to make it simple. Okay, I've read a lot of books. This is the closing here. I've read a lot of books. Everything from Cisco Press books to just, third-party books to things on the internet and watching videos from different, people like teaching these topics, and they just make it seem complicated. Some try to make it seem easy, but it's easy. It really is. Just divide by 4. And you'll be all set. So have a good day.